Okay, chapter 3, section 1 starts with identifying pairs of lines and angles. So we're going to be looking at what happens when certain lines are oriented or positioned in certain ways, certain things that happen when we have lines in specific ways. So the first things that we got are parallel and skew lines. So we're going to talk about the word skew and the word parallel. Parallel is like a set of train tracks. There are two lines that will never cross each other. They keep running at the same distance from each other always. So parallel lines are just coplanar lines. They're on the same plane that they never intersect. Will never, no matter how far they go, they will never cross each other. So again, if like train tracks did cross each other, we'd have lots of train wrecks across the United States. So then we get skew lines, and skew lines are non-coplanar lines, meaning they're not on the same plane. So if you notice, like this line it really shouldn't be bent like that. It's just how part of the notes there, like it's really supposed to look like. They're not supposed to be it is supposed to be a diagonal line. It's just not supposed to be like crooked like that. So if you imagine one line, when we talk about skew lines, it's on the plane right there. And the second line, while one point may be on the plane, is not on the same plane. The second one is like was like a pen jabbed through this piece of paper coming out the other side. So they are non-coplanar lines that are neither parallel nor intersecting. So if you notice here, these two lines are not on the same plane. They're definitely not on the same plane. Like they're not laying on the same thing, but they're also not parallel. So this is another set that will never touch each other, because if you look right here, this guy right here is going left and right, and even if it goes forever left and right, it's going to keep going, whereas the one in the back, let me change colors to green just to separate the difference. This one is kind of going up and down a little bit diagonally, but it's further in the back of this plane, which means that it's actually never going to touch this line. And you might be like, but wait, isn't it going to touch it here? No, because those dashed lines means it's going through the paper and coming out the other side. So it's actually never going to touch it. If you could imagine here, if there were a line, let me actually draw one on here. I can actually draw a line on a plane, a piece of paper just like this. That's kind of like that same line. And I can take my stylus and shove it through the paper. And if you imagine there, you could see that no matter what, we've got that same situation. We'd call these two skew lines because while one of them, I have to kind of turn it like this so you can see it, while one of them's on the paper flat, the one that's being jabbed, the stylus being jabbed through the paper, is kind of going up and down. It will never hit it. They'll never intersect. They're never going to touch each other. However, they're also not parallel. They're not on the same plane in equidistance. They don't look like train tracks. They're not kind of that same, like laid right next to each other. So that's the difference between parallel and skew. While they both, while neither one of them will actually intersect, they have different ways that they're laid out. One of them are equidistant from each other. The parallel lines, they're always the same distance apart, whereas skew lines don't have to do that. They're not even on the same plane. Yes, ma'am? Because to be on the same plane, they have to be laying on the same plane. Just because they're touching the same plane doesn't mean they're on the same plane. This line that I drew on this paper is on the plane. This is actually just passing through the plane. So this one that I jabbed through it, it's just going through there. It's not on there. Literally, to make it on there, I could just lay it on there. Now it is on the plane because I laid the stylus on top of the paper. Now both those lines would be on the plane. However, when I shove it through there, it just intersects the plane. It just crosses it. Yes, sir?
So theoretically, if the line that you drew on the paper, a plane was going through that, and that the stylus that you jabbed through was closer to that line, could they be coplanar because it's on that other plane?
Could what be coplanar? Like the two, like you're saying that if another plane crosses this?
Yeah.
Okay, so you get something like this?
Right.
And then what?
And then the stylus, instead of being jabbed far back, right there on the line.
Well, then it definitely wouldn't be skew. Because, look, it says right there that they don't intersect. It can't intersect the line. It wouldn't be skew if it intersected the line. It would just be two intersecting lines.
Okay.
All right, so parallel planes. We've talked about parallel lines, but planes are those flat surfaces there. They are planes that do not intersect. If you notice here, I'm going to use some colors to separate them. Let's imagine this is like an Amazon box, right? You get something in the mail. You've got the top of this box, And this whole top is parallel to another plane, like meaning that there's another plane that it will never touch. Which plane is the one that it will never touch? Yes, ma'am.
F E, like the plane F.
Go ahead. F-E what?
F-E-C-T.
F. So we only need 3. F-E-C would be perfect. That right there, which is this bottom plane. Those two will never touch each other. They are parallel. Is there another set of parallel planes out there? Yeah.
A-G-D and B-H-E.
A-G-D, this one over here, and B-H what? B-H?
H-E.
B-H-E, this one over here. Those two will never intersect. Is there somebody different, another set of planes that will never intersect? Somebody different. I love you to death, but you already gave me 2. Yes, sir.
H-E-F and A-B-C.
H-E-F is the front part of this box. Like, imagine the front part there. And then what was the other one, I'm sorry?
A-B-C.
ABC, the back part of the box. So I'm kind of going over some of the things I've already done, but the front of the box and the back of the box, they are parallel. So imagine like if you got a box from Amazon, if this were there, the top and the bottom would be parallel, the left and the right would be parallel, the front and the back would be parallel. They are planes that will never, even if they keep going on forever, they will never intersect each other. All right, so we've got the parallel postulate and the perpendicular postulate. If there is a line and a point that is not on the line, there is exactly one line through the point parallel to the given line. What they're saying is this. Let's say that you've got a line and it looks like, let's just make it maybe look like this. I'm just making a generic line. If there is a line, okay, there's a line. And there is a point that is not on the line. Okay, here's a point that's not on the line. Then there is exactly one line through that point that I just added, that is going to be parallel to the given line. Right, I can't just draw any line at this point now. Through that red part right there, I have to kind of draw a very specific kind of line, and there's only one line that will be parallel to it. Now, I tried to make that as parallel as possible. Unfortunately, this one does not allow me to draw the straightest of lines. So, again, if I have a line and there's a point that's not on the line, there's only one possible line that could ever be parallel to it that goes through that point. Only one way to do that. There's no other way. Now, if you didn't limit me to that point, I could draw an infinite amount of parallel lines. I could draw a parallel line here. I could draw a parallel line here. I could draw a parallel line here. I could draw them all over the place. But what we're looking at is if I have to go through that point, there's only one parallel line I could make. So the perpendicular postulate says something kind of similar, but now we're talking about being perpendicular. What does perpendicular mean? Like in plain English, what does it mean? So we use this symbol to mean perpendicular, but what does that mean?
Lines that intersect and form 90 degrees.
Okay, so again, perpendicular means that they come together to form 90-degree angles. So it says, if there is a line, okay, here's a line, and a point that is not on the line, so let me just do that same kind of setup there, then there's exactly one line through the point that is perpendicular. So there's only one way that I can make a line that would be perpendicular. I can't do an infinite amount of lines because it would change that angle. I need to form a 90-degree angle, and there's only one line that can do that. So her question was, what if I didn't do the line there? Like I kind of did it to the middle. Would it still count if the point was like over here? For sure, because even if it, that was not straight at all. Even if it hit right there, then it could still make a 90-degree angle. It's just not in the center. So making the 90-degree angle is a separate thing from being in the center. I just did it in the center because obviously it's just easy to cut right down the middle. All right, in my opinion, we start to get to the most important parts of this lesson right now. So like these are the most important things that we're going to talk about today right here. So I'm going to be talking about a transversal a lot. You're going to hear me say transversal a lot. And this is what a transversal is. It is a line that intersects two or more coplanar lines in different points. So what we've got here is if you look at line J and you look at line K, would you agree that line M intersects both of them? It hits the first one, it hits the second one. Are we okay with that? It intersects both of them. We call this a transversal when one line is crossing over two or more lines. So like it could be more, it could be 20 lines. But obviously it's easiest just to start with two. But what happens, the reason that we're going to do this why do we care about this crossing it, is it creates, when it crosses, it creates 4 angles up here. Those 4 angles up there, let me just highlight them. It creates angle 1, angle 2, angle 3, and angle 4. Those angles didn't exist until that line cut through there, and now there's an angle there. But it also created a second set of angles. Angle 5, angle 6, angle 7, and angle 8. So the first thing to note is that this line that has crossed over 2 other lines, that red line, line M, is called a transversal. It just means a line that is crossing over 2 other lines. That's all it means in plain English. Now, we've got 8 different angles that were created there. The 4 red ones on top and the 4 blue ones on bottom. We're going to start talking about exterior and interior angles, and it's important to know what I'm looking at when I'm calling them exterior or interior. So these 2 lines here that we had these 2 lines that got crossed. Imagine them like castle walls, right? They are like the walls to a city, and they are protecting all these things on the inside of the walls, okay? That's what I'm going to talk about when I talk about interior. All of this is between those lines, so I'm going to call that the interior. So angle 3 and angle 4 and angle 5 and angle 6, those are all called interior angles. Bless you, because they are on the inside of those 2 green lines. Not the transversal. I'm not looking at the transversal. I'm looking at the other 2 lines. And they kind of create walls to this city, if you will, this castle, whatever you want. They hold things inside of there. So 3, 4, 5, 6 are on the end. There's a lot of sneezing going on. There's 3, 4, 5, and 6 are all on the inside there. Well, if those guys are on the inside, guess what? These guys must be on the outside then. 1, 2, 7, and 8. They're on different sides of the walls. One's on the north side of the wall, one's on the south side of the wall, but they're still called exterior angles. So all I'm looking at to decide whether something is interior or exterior, I'm looking at the 2 lines that are not the transversals. So line J and line K. If it's between those 2 lines, that is the interior. If it's not between them, this is the exterior. It's outside of those 2 walls right there. Exterior. So I'm going to be talking about exterior and interior, and this is going to expand. I'm going to talk about interior angles, exterior angles. So you're going to have to know what I'm talking about and how did I know they were interior, exterior. Well, I'm using that every time. That's what I'm going to do when I look at angles. All right, so now we get in even more specific. So we're going to talk about interior angles and exterior angles, but we're also going to give them more specific names. The first one we're going to talk about is alternate interior angles. So check it out. I'm going to first identify where the interior is here. Here are 2 lines and a transversal that is coming across it. Here's the transversal cutting across, going like north-south there. It creates 8 angles. Which 4 are the interior angles there? Yes, ma'am.
Angle 3, angle 4, angle 5, and angle 6.
Good. So all of this is the interior. So I'm just going to go like this. I'm just color coding because in the beginning it's nice to know like where was the interior. That's all interior. But they're talking about this word alternate now. Alternate is another word that we're adding on there. Alternate interior angles are 2 non-adjacent, so they cannot be right next to each other. They cannot be next door neighbor angles. Like 3 and 4 are next door neighbors. They can't be those 2. Set 5 and 6, they're next door neighbors. It can't be those 2. They have to be non-adjacent interior angles on opposite sides of the transversal. So check it out. The transversal is this line going up and down. I need 2 angles that are in the interior. They're on opposite sides of the transversal, but they can't be adjacent. They can't be next door neighbors to each other. Give me an example of that.
Okay, well, either 2 or 3.
Well, 2 and 3 would not, 2 is not an interior angle. Remember, I have to be on the interior angles. I can only look at interior angles.
So, 6 and 3 maybe?
6 and 3 are definitely, look, so here, this is on the inside, on opposite sides of the transversal. They're also not adjacent. They're not next to each other. You said it could be this, or what's the other combination it could be?
4 and 5.
4, and 5. These are called alternate interior angles, and we're going to learn something special about these angles. They have very special connection. 5 and 4 are an example of interior angles, and 3 and 6 are an example of alternate interior angles. Alternate meaning on opposite sides, interior meaning they're on the interior. Now we're going to apply that same thing, and we're going to do the alternate exterior angles. Well, exterior just means they're on the outside, so it's got to be these angles and these angles, and by definition it says two exterior angles that are on opposite sides of the transversal. So they have to be two things on opposite sides of the transversal, but actually not just like this. They also cannot be adjacent. So I realize it says so let me just say they cannot be adjacent. So let me just add that in there, non-adjacent. Meaning 7 and 8 are exterior angles, and they're on opposite sides of the transversal, but they are adjacent. It can't be those. Colette, you got something for me?
1 and 8 and 2.
Good. 1 and 8 are on the exterior. They're also on opposite sides of the transversal. We call those alternate exterior angles. And you said the other combination was? 2 and 7. So we've got angle 1 and angle 8. And then we've got angle 2 and angle 7. Now, we're going to learn something that's special about these combinations, but we need to know when I say alternate interior angles, alternate exterior angles, just so you get an idea where this is going, that's going to be something you're able to write in a proof. Why is that true? Alternate interior angles. Why is that true? Alternate exterior angles. But we're not to why, what did I learn from this? All we know is now that's the position they're in, but we'll talk about what it means in a little bit. We're just identifying that 1 and 8 are alternate exterior angles, 2 and 7 are alternate exterior angles, 3 and 6 are alternate interior angles, 4 and 5 are alternate interior angles as well. All right, so now we've got two others that we're going to learn. Same side interior angles. This is sometimes in some books also called consecutive, meaning right next to each other, interior angles. You might see this. I'm only writing this down because I tend not to use this word, but the book will sometimes switch to consecutive interior. So just so you know what I mean, same thing. Same side interior angles are two interior angles. So we know we have to be on the interior. Let's just kind of here's my interior here. Two interior angles on the same side of the transversal. So they have to be on the same exact side of the transversal. There's the transversal again. So let's talk about what would meet that definition, that they're in the interior, but they're also on the exact same side of the transversal. Yes, ma'am?
Angle 3 and angle 5.
Angle 3 and angle 5 together are a pair of same side interior angles. And what's the other one?
Angle 4 and angle 6.
Angle 4 and angle 6. Angle 4 and angle 6. I promise you, we're going to learn more about why do we care about these. Why do we care about their names? We're going to learn why, but first we got to get down their names so when I refer to them, you're like, oh, those angles have a special relationship? What is it? I'll tell you about them in a bit. Yes, ma'am?
So, same side interior, they're allowed to be adjacent.
Yes. So, because we want them to be on the same side. But notice 3 and 4 would not work because they are not on the same side of the transversal. They're on opposite sides of the line. Now, the one that everybody kind of messes up a little bit more, so I'm going to take a little longer on this one, is corresponding angles. So, 4 and 6. Let me just drop these arrows there. I'm going to rewrite that. So we had angle 4 and angle 6, and we had angle 3 and angle 5. All right, so corresponding angles are two angles in corresponding positions, meaning they're in the same position relative to the two lines. So check this out. What it means is that when these lines got crossed by a transversal, it created 4 angles. If you will, there is, of these top 4, I'm going to look at these top 4 for a minute. I'm going to call this one the upper left-hand angle. This is not a technical term. I'm just trying to show you the relationship that I'm doing. That's the one in the upper left, right? That angle's in the upper left. And this number 2 is in the upper right. And 3 is in the lower left. And 4 is in the lower right. Are we okay with it? I'm just giving it a generic name just so you know why I'm like, 1 is in the upper left, 2 is in the upper right, 3 is in the lower left, 4 is in the lower right. And I'm going to do the same thing for the bottom ones. This one is in the upper left of this intersection. There's like this intersection here that's in the upper left, upper right, lower left, lower right. This writing this UL and UR, LL and LR, that's not a technical thing. It's just going to help me illustrate what I'm showing you. So when we do corresponding angles, they are 2 angles that are in the same position. Meaning 2 angles that are both in the upper left, 2 angles that are both in the upper right, 2 angles that are both in the lower left, or 2 angles that are both in the lower right. Sometimes I use like northwest, northeast, southwest, southeast. It means the same thing. It's just they're in that same position. So let's try to find combinations of angles that are in corresponding positions, that they are corresponding angles. What you got? Give me one.
Angle 1, angle 5.
Good. Angle 1. Actually, I don't want to make them like they're congruent there because it doesn't look like they're congruent. So the first set we've got is angle 1 and angle 5 because they are both in the upper left-hand corners. Somebody different. Give me another set. Yes, ma'am.
Angle 3 and angle 7.
Angle 3 and angle 7 because they are both in the lower left-hand corner. Somebody different. Give me a new one. Colette. Angle 2 and angle 6 because they are both in the upper right-hand corner. And I've got one more combination for somebody who hasn't gone yet. Yes, sir?
Angle 4 and angle 8.
Angle 4 and angle 8 because they are both in the lower right-hand position. We call these corresponding things, like corresponding angles, sorry, not corresponding things. Corresponding angles because they're both in the same position. Both angles 1 and 5 are in the upper left. 3 and 7 are both in the lower left. 2 and 6 are both in the upper right. 4 and 8 are both in the lower right. You don't need to label them like this if you don't want to. I'm just trying to illustrate the way my brain is looking at it, going, okay, that's how I know which ones go together. The one in the upper left, the one in the upper right, lower left, and lower right. It doesn't mean anything other than they're in the same position. They're corresponding angles. You're going to be given a diagram and asked to name the corresponding angles, to name the same side interior angles, name the alternate exterior, alternate interior angles, that you're going to have to be able to identify them by looking at just a diagram. There is such a thing that we could say that they're exterior, but we don't care about that one because there's not a special relationship for same side exterior. There are special relationships for all of these that we're going to get into. I don't believe in this lesson. I think in the next lesson. So we don't actually care about the same side exterior ones because we're not going to have any special. Okay, yeah. No, good question. So same side X relationships with them. So let's play a game of true or false. A transversal intersects only parallel lines. False. We saw that it just... So definitely false because we saw that we actually intersected lines. It just means a transversal is a line that crosses over 2 other lines. It didn't say they had to be parallel. Skew lines are not coplanar. True. We said they are not on the same plane. While one of them can intersect the plane, they are not on the same plane. If 2 lines are coplanar, then they are parallel. False. There's a certain scenario. Remember, is like if they are on the same plane, then they would have to actually be parallel, meaning they're equidistant apart. But they could be on the same plane and look like this. That's not parallel. So this one would be false. If 2 lines are parallel, then exactly one plane contains them. True. To lie on those, it'd have to be one plane that contains them. Now, you might be like, but you could draw it bigger than that. That's still the same plane. Yes, ma'am?
You can't draw like 2 parallel lines that they're not in the plane.
So you could draw them that they're not in a plane, but there would still only be one plane that goes around them. Because look, watch, I need 2 points for these and 2 points for those. So right there, I've got 4 points. And remember, by definition, what I need for a plane is 3 non-collinear points, which I have there, 3 non-collinear points. Hi guys, come on in. Somebody had a question. Who's the quote? Yes, ma'am.
Okay, so if it's if they're coplanar, what if like, let's say a plane is here, and you have a line up here and up here, how is that coplanar?
Okay, so great question. So her question is, let me get like obnoxious here and get on a chair so everybody can see me. So if I fall and break my leg, just remember your next geometry teacher is not as good as me. Okay, so two parallel lines. She was talking about two parallel lines like this. Could they be on the same plane? They sure could. It would be this one that's flat. But so like if I put it on a piece of paper, these are parallel and they're on the same plane. Oh, I'm going to drop these all over the place. They are on the same plane just like that. But her question is, what if I put them like this though? I just messed it up. I put it like this. What about that plane? Well, that sure is on a plane too. It's just that plane is a different plane that goes like this. So there's always a plane that contains two parallel lines. It just may not be the plane that you think it is. So that plane always exists, three non-collinear points. All right. Welcome, guys. Give me 1 second. We're just finishing up our last slide, and then I want to you guys a bit. All right. Last but not least, let's wrap this up. Give me a pair of alternate interior angles. Yes, ma'am. 2 and 7 are both on the interior of these two lines. As we said, they're on alternate sides. So 2 and 7 are a great pair. Angle 2 and angle 7. Give me a pair of same side interior angles. Yes, sir.
6 and 7.
6 and 7 are on the same side. They are both in the interior, angle 6 and angle 7. Corresponding angles, one's in the same position. Audrey. 5 and 7. Notice 5 is in the lower left here, 7 is in the lower left here. Of those two intersection, that would be corresponding angles as well. All right, you guys have homework to do. Let's get started on it.